Alright, so normally really bad at video documenting my projects. I usually start something, get partway through, it's like, oh, I should take some pictures, maybe a few video clips. Finally gonna start one from beginning to end. Hopefully film most of the process. Ups and downs, if it works, doesn't work, we'll see. So here's my starting parts. What are we gonna do? What I wanna do is take my cheap FPV goggles and basically turn them into a night vision headset. So, how do we do that? So I found that most FPV cameras do not have an infrared filter because they're made to also fly in low light, like evening kind of thing. So it will do the same thing. If you have an illuminator, pitch black, it'll give you a picture. So I had this already in one of my RC planes. Took it out, different antenna. So that's the base. It's going to be the camera, transmitter, receiver. So the plan is to design and 3D print a unit that will pretty much snap onto here, have its own power supply, and then it'll be one-to-one, no zoom, night vision. And to do that, of course, we're going to have the camera, probably be somewhere in here, and then I have two different infrared flashlights. This one is this kind of a wide beam, just put out everywhere in front of you. This one is zoomable. So if you want a spotlight further away, you can do that, which there'll be individual switches for both. Main power switch, cooling fan, because these transmitters do get fairly hot, especially in an enclosure. Voltage buck converter to bring down the 11.4 volts to operating for this, I believe, is 5 volts. This one is 1.5, which means I'm going to need another voltage converter. Since it's self-powered, I want it to be able to disconnect, and then you can set it somewhere and walk away and still see in total darkness what the camera sees. So it'd be like a sentry. So that's the plan. And I guess I will bring you back when I have something to show other than parts and an idea. Okay, now let's run through this. So, we have a 3S LiPo battery providing 11.1 volts. Now it's going to have connections to the outer case for charging, so I want to take it open to charge it. Of course, the ground will be common to everything. The hot's going to go through a main on-off, and shut everything off. When that's on, it's going to provide power to the transmitter, which has the antenna and camera connected to it. It's going to provide power to this voltage converter that's going to convert 11.1 to 1.5, and this voltage converter which will convert 11.1 to 4.5. Now immediately out of this one, it'll go down, so this cooling fan will be on anytime the main is on, because when this transmitter is on, it produces quite a bit of heat. So I need that cooling fan running all the time. Okay, here are our components. This is our tiny 3S LiPo. I'm not really sure how long it'll run off of this. I think just the camera and the lights. It should be a fair amount. Once it's all together, I'll actually do some testing on that. This is the infrared floodlight. It has 9 individual IR LEDs. And then the spotlight, you see the lens on there. It's actually adjustable for distance. Probably mostly stay out like that for further away since we have the floodlight there. This will be the main power. Individual on-off for the IR lights. It's our teeny cooling fan. And these are the voltage buck converters. Now these will take in, I think, anywhere from 3 to 30 volts DC, and you can adjust it, I think, down to 5. Oh no, you can go, I think you can go as low as you want. But you adjust it here once it's connected, and then once it's set for that voltage. And here's our transmitter. Here's the actual transmitter unit. You can scroll through, I think, 30 different channels. The massive channel of the receiving goggles. It's the antenna. Screws on here. There we go. And this will be just sticking up out of the case. And then it's our little FPV camera, which will connect here. And this does not have an IR filter, which means at night it'll pick up a lot better. And then if you have an illuminator, it'll pick it up just like it's a flashlight. And it's adjustable for focus. Once it's set, it's set. Okay, so for the battery charge lead, I'm actually going to use 16 gauge, but everything else is going to be nice thin 20 gauge. Nothing's going to really pull that many amps. So I need to connect all 4 of these to this connector. We'll plug into the battery. Other end of that will be duplicate, like the battery, that will glue into the side of the case. So when we start doing that, I'll probably speed all this up so you don't have to sit through it all. Okay, so I need to figure out which lead is positive and negative on these IR lights. So for that, start up the voltage supply. We'll do the floodlight first. So let's go to 4.5 volts. Just see these always emit just a tiny bit of red light. I can see that, so that means the center in there is negative. Alright, let's try the other one. Let's crank it down to 1.5 volts. This one's going to be a little bit more difficult. Let's see. There we go. I'm going to assume the same thing. Yep. center is negative. Okay, so in the case, the two voltage regulators or voltage converters are going to stack on top of each other like this. So I can go ahead and make jumpers for positive and negative, connect them together, and then just bring the power into one of them. So let's do that now. I think probably about 1 inch. Okay, let's go ahead and set these voltage converters to the right voltage. I'm going to use the top one as a 1.5, bottom one is 4.5. So we will plug in our 11.1 volt battery, turn on the power, got our LEDs there. Now, read our voltage. Right now it is putting out 10.82. Way too much. So all we have to do is turn this down. There we go. Now it's going down. It always takes a long time. It's always maxed out. Five, 4, 3, 2.5, 1.8. Not 1.5. Let's make it 1.55. And now the second one, of course, is at the 10 and 4.5. Okay, those are set and they should stay set. So I got the main case printed today. And some brackets. Okay, so the way I put these inserts in, take the insert, put it on the side screw, it's appropriate for it, and then you just heat it up. Okay, so pretty much all the wiring is done. I went ahead and just went with a single on-off switch instead of switching each IR illuminator separately. It doesn't really make any sense. They'll just both work together, which would be just fine. So yeah, now it's time to make a test. I went ahead and mounted the camera in the 3D printed housing. Went ahead and put the attachment arms on there as well. So before I start mounting all the components in here, I'm going to power it up and give it a test. Yeah, let's do that now. 3-cell LiPo. And the power. Power on the transmitter. See just a faint red glow coming from the illuminators, which is good. Now I have an FPV monitor here. I should be able to turn that on. And it's already set to the frequency of the transmitter, because I've used this transmitter in an RC plane before. So there we go. Now let's see if the illuminators are working. So if I turn this light off and we move around this illuminator. Oh yeah. Yep. I think we're good. So I have a cover here that I will bolt on. So we'll open this cover. Has a 1/4-20 nut pressed in there, and that'll allow me to set this onto a tripod if you want to set it off by itself to stream back to the goggles. Or these, which are going to glue onto here, will allow you to just attach them right to the goggles like that. So let me get this bottom plate bolted on, and then we'll work on gluing the mounts to the goggles. Okay, unit's done. And now these tabs, which connect with these thumb screws, will glue onto the top of the goggles here. Kind of like that. It'll still leave a gap underneath for the fan to pull in cool air. Before I glue that, I need to clean it and use some CA glue. I think that'll do. Now we just wait for it to cure. Okay, time for some testing. So, first thing, we'll power the goggles. Here it's searching for a signal. Power the unit. And I can see video. But for you, I'm going to set the camera up on this remote unit. So we power that up. Now, you can see what the goggles see. And what I'm going to do is set one camera up on that, take a camera out with me so you can see how dark it is, while also seeing what you can see with the IR night vision. So let's get that set up. Okay, I'm going to put the goggles on. And time to go outside. Oh, good. Hopefully the video signal back inside isn't breaking up too much. course, as I go around the back of the house, it probably will start to, because it's trying to go through all the brick and cement of my house. But let's zoom in with the IR light. Zoom out and back out. Like, you see the dust and pollen in the air really well. Okay, head back up towards the light. And back to the house. Now you can see the color. Once the regular light is back, you can see everything in color again. And there we go. So that is the build video for my DIY night vision goggles. Pretty happy with this one. Might tweak around a little bit, especially with that floodlight. I think I can get more out of that than what I'm getting. But overall, super happy with this build.